Suppose the position is given by this function and t is in between 0 and 8 inclusive. In part A, we are asked to find the velocity function. Velocity is just the rate of change of position, so velocity vt is simply the derivative of this function, which is 24x minus 4x squared, just like that. So it's 24 minus 8t. Now we need to find when is the object stationary, not moving, moving to the right and moving to the left. Stationary means when the velocity is 0. Okay, so we set the velocity 0. We just found that is 24 minus 8t equals 0. Move 24 over, subtract 24 from both sides, negative 24, and negative negative cancel, divide by 8, so t equals 3 seconds. So let's make the timeline here. We are considering this function position from 0 through 8, and we just found at t equals 3, the velocity is 0. That means the object is stationary. Okay, and we need to find when is the object moving to the right and moving to the left. So stationary, so stationary at 3 seconds. Now take any number in between 0 and 3, let's say t equals 1, maybe 4, and plug this into the velocity function, which is 24 minus 8t. If we plug in t equals 1, we get 24 minus 8, 16. So the velocity is positive here. So v is positive here. Plug in t equals 4, 24 minus 32, negative. So velocity is negative here. So the velocity is positive means the object is moving to the right and the object is moving to the left. Okay, object moving to the right on the interval starting 0 inclusive. Look at the time interval 0 through 8 and 3. Okay, an object moving to the left on after 3. Okay, at 3 is stationary, 3 through 8. That's part A. Now let's go to part B. We need to determine the velocity and acceleration at t equals 1. So we already have the velocity function. All we have to do is plug in t equals 1. And by the way, acceleration is the rate of change of velocity. So we need to find the derivative of this velocity function and evaluate at t equals 1. So velocity at t equals 1, so v1. So pretty much plug in t equals 1 here. So the velocity after 1 second is just plug in here, 24 minus 8 times 1, it's 8. So that's 16 feet per second. Okay, it's the velocity, so feet per second. Now we need to find the acceleration. Acceleration is the derivative of velocity. Let's find the derivative of 24 minus 8t, 0 minus 8, so it's negative 8. By the way, the velocity at any time, acceleration at any time t is negative 8. So after 1 second or after 5 seconds, same thing. Okay, this is always the same acceleration. That's feet per second, feet per second squared. And this is in fact acceleration after at t equals 1 as well, same answer. Okay, there is no t, that means anytime the acceleration is negative 8. Part C, determine the acceleration of the object when its velocity is 0. So velocity 0 means when means we want to find the time t setting the velocity 0. So set the velocity 0. And here in part A we found the velocity 24 minus 8t. And by the way, the velocity is 0 at t equals 3. So we can just say, we don't have to simplify again. It's the same thing. So we can simply say velocity 0 at t equals 3. Okay, and we're going to find the acceleration at t equals 3. So acceleration at 3, and we figured out that's -8. There is no t, so regardless of the time, the acceleration is always -8. -8 feet per second squared. Okay, there is nothing to plug in here. That's why it when the velocity is 0 or at 1, every single time the acceleration is -8. Part D. On what interval is the speed increasing? Speed. So speed is the absolute value of velocity, because the speed is always positive. Velocity can be negative or positive. When something is moving to the right, velocity is positive. Something moving to the left or backward, negative velocity. But speed is always the same, always the positive. So speed is in fact absolute value of velocity. Okay, we want to find the interval. That means during when during t equals somewhere to somewhere, is the speed increasing. So that's positive. So all we have to do is, it's difficult to find speed. What we do is, let's graph the velocity function, and from there we can graph a speed. So the graph of velocity function vt, that was found in part A, that's 24 minus 8t. Let's graph this. You can use a graphing calculator, or this is just a line. When t equals 0, because we have to go from 0 through 8, that's the time interval given in the question. So at 0, this is 16. So at 0, that's 16. At 3, we know this is 24 minus 24, 0, 8 times. So at 3, it's 0, it's going down, and we have to go all the way to 8. Here is 3, so it's just decreasing in this way. This is the graph, approximate graph. You can get better graph using your graphing calculator. And we know that the slope is always -8. That's the acceleration, by the way. It's going down in this way. That's the velocity. Now we want to graph the speed function. Graph of speed. So speed is always positive. So this below this time t-axis, this is negative. So we have to move this up. So it will be the same thing here. The speed now here is 3, here is 8, 0. It started at 16. It's going down. Now the speed can't be negative. It cannot go below this t-axis. So we need to make it up. Okay. So like this. So this is the speed function. And if you look at closely, it's going down, decreasing, going up, increasing. Okay. And at 3, it's 0. And we are inclusive 0 and 8. So the question was, when, on what intervals is the speed increasing? So the speed is increasing on starting 3, but 3 is not inclusive, all the way to 8. 8 is inclusive, by the way, after 3 seconds. Final.